Thank you very much for inviting us to come talk about accelerating computational reproducibility in economics. I'm Fernando de la Guardia. I work as a project scientist at BITS, and I'm also joined by my colleague Katie Hoeberling. And basically today I'm going to be talking to you about this exciting new project that we have been working on for about a year now. That it's a set of guidelines and a platform to accelerate computational reproducibility in economics. The guidelines are ready and are public. There are some minor adjustments that we're still working on. The platform, it's still under development. There is a website for it, and I will show it to you, but we intend to be ready for beta usage by early November. So let me start telling you just briefly about our organization. As David says, not to be confused with BITS with a D. We're BITS with a T, the Berkeley Initiative for Transparency in Social Sciences, where we work to improve the credibility of science by advancing transparency, reproducibility, rigor, and ethics in research. A lot of what we do, it's build a community of practice around transparency, fund meta research, and promote initiatives like this one and others around increasing transparency and reproducibility, both in research, but also in its connection with policy. We're part of the Center for Effective and Global Action, and particularly this project, ACRE, this is the list of all the great people that has worked and are currently working in this project. The PI is Ted Miguel, and the co-PI is Lars Bill Huber. I assume that for a forum on computational social sciences, maybe I don't need to talk much about reproducibility. I will show you just what probably most people in this talk know already, but basically there's this idea of a reproducibility crisis, either on the column to the left. There's good evidence on that the studies, the replication rates are not so high. Replication understood as same methods over a comparable sample, obtaining the same findings. And more important for our conversation, reproductions, understood as same data, same code, obtaining same results, are also, those rates are alarmingly low. And some evidence suggests for economics. And so that's a space to talk about, to focus on reproducibility. Another motivation is this talk that if you care about reproducibility, you have seen this talk a billion times, this quote, but the idea that an article about computational science is it's in a scientific publication that's not the relevant scholarship unit. It's merely advertising, and the actual scholarship, it's the entire computational environment behind the particular display items or figures or tables. This quote is usually set up in a context to say we need to increase computational reproducibility for better pedagogy, and also to have a clearer pipeline for an incremental generation of knowledge. And those are the usual context in which this quote is put up. We also wanna suggest that an under-discussed topic is that this augmenting computational reproducibility could have a possible positive effect on diversity, equity, and inclusion, in the sense that you don't, as reproducibility increases, you don't need as much of the right connections or the right language skills in terms of appropriate politeness or something like that in order to obtain the materials to reproduce a paper. The third and last motivation is that we want to prevent loss of knowledge. And this comes particularly to every semester around the world. Students in graduate studies in economics take some type of course that it's an empirical something economics or applied something economics, so empirical labor, empirical health, empirical education in economics. And a typical assignment consists in reproducing the results of a paper and possibly testing the robustness of its results. So an assignment implicitly or tacitly might have these stages where in the first stage, the student identifies if the paper has data or code, and learning whether a paper has data or code is new knowledge, that it's not codified anywhere. So that's knowledge that is generated. Later on, the reproducer might assess the degree of reproducibility of a specific part of the paper. Again, new knowledge generated that it's not encoded or preserved anywhere. She might improve some component of the reproduction materials, fix some paths, added some libraries, translate the entire script into an open source statistical software, and also might test the results and how might they be robust or not to additional specifications that are not in the paper. And particularly when the results are they confirm that the results in the paper are robust to new tests, there are little incentives to codify this knowledge. So each semester, in each of these previous steps, there's going to be new knowledge, but this new knowledge is not going to be disseminated in a systematic fashion. So at best, you're going to have an end of semester report or a presentation that is not going to be published. A key problem is that the language across courses and across universities and across countries is not going to be standard. We still have not agreed on whether or not we're going to describe this process as a reproduction or a replication, and many other definitions. And there are some attempts to get at this problem, particularly the replication wiki, but they are much more oriented towards the generation of a full new paper. And we think that this knowledge that I just described, it's not so well suited to fit on a paper. It's a little bit too much to ask students that just finished their semester to write a full paper if they might not see a publication out of it. But we do see a process, we do see a gap in standardizing these definitions and being able to properly store this knowledge that was generated. So that's where we basically see the ACRE guidelines and the ACRE platform coming in. That's in terms of the motivation. Before I jump into the solutions or our proposal, I wanted to stop if there might be any questions or comments about the motivation. Okay, so what is the context for our project, for ACRE? So in 2006, the American Economic Association creates its first data policy, where they request that some data must be published with a paper that will be published in one of the AEA journals. So it did not specify specifically what data. It could be the final analysis data. It could be some intermediary file. Hopefully might be the raw data. But also this policy also allowed for waivers, and waivers that were available and used extensively. In 2019, the policy got a major update. Basically, the AEA hired a data editor, Lars Hoover, and Lars came out with a set of proposals that basically are encapsulated in these points. That first, authors must post all the data and code, and the publication is going to be conditional on verifying the reproducibility before granting acceptance. If the paper uses confidential data, the authors must document extensively how to document that, how to obtain that data. And a new requirement also is that authors have to post all the cleaning code, even if the data is not public. So before, the cleaning code was not even mentioned. Now there's an explicit requirement to post cleaning code, and also if the data is not accessible, they're still going to request for authors to publish the cleaning code. And there's more details to it, and I put the link to the AEA data editor website there. So the way we use this to frame our initiative and think that after 2019, in the AEA journals, we should expect high levels of computational reproducibility. But we should not demand 100% reproducibility before. Before that, I just show you what were the standards. So it's unfair to request of authors to achieve 100% computational reproducibility. However, we can use these new standards to guide students in assessing reproductions, in identifying gaps, and hopefully in improving some dimensions. The key challenge here is that reproductions tend to gravitate to binary judgments. So the early career researchers have incentives to emphasize unsuccessful reproductions, and original authors also have incentives to, in their senior position, to deter in-depth reproductions from early career research. So the incentives are going in a direction of a adversarial engagement. And if you add on top that the media basically focuses a lot on this does not reproduce and eye-catching headlines, it's a bit of a recipe for adversarial environment. So our approach is we do not want to talk about paper X is irreproducible. We do want to say something like result Y in paper X has a high or low level of reproducibility according to several reproduction attempts. Moreover, improvements have been made to the original reproduction package, increasing its reproducibility to a higher level. And here the emphasis is in levels as opposed to a binary assessment. In several reproduction attempts, we want to collect several reproduction attempts before saying anything about a paper. And we also want to guide the reproducers in how to systematically report their improvements in order to increase its reproducibility. And the way we think about that is that we try to move away of thinking of the paper as a one unit, and we try to break it into pieces where each paper can contain several claims or major hypotheses to be tested. And each claim is going to be supported by several display items. These are going to be tables, figures, or inline results. And each of those display items is going to in turn contain specifications. And we want to guide the reproducer to assess the reproducibility of a display item and focus on a pre-specified specification that they're going to be testing. A large part of this exercise, it's basically along the lines of standardizing language. So we're not claiming to invent something wildly new here. It's just we're trying to, at least for this exercise, agree on on certain definitions. So just as an example, we try to differentiate very clearly what a replication is. Again, same method, different but comparable data from a computational reproduction, and we try to not use the word replication ever again in our guidelines or in our materials. We basically need to define all the materials of a reproduction. So we claim that that's a reproduction package. There are things like raw data and analysis data that also require some distinction. And there's also, we need to define along the lines of what's a paper that I might reproduce and a paper that I will actually start assessing its materials for reasons that I'll explain in a second. And basically a large part of this exercise is about basically coming out or adopting what we see as the most common definition of this, but also leaving it open for the community to jump in and say, you know what, this definition maybe it's not the most sensible one, this one's more popular, and they can modify it in the guidelines and submit a pull request for editing the guidelines. So that's our framework, and that's how we approach this problem, this initiative, and we break it into, we break the exercise into 4 stages. The first stage, we ask reproducers to, we call the scoping stage, where we ask reproducers to either be assigned or select a candidate paper. And this paper, the only thing we ask them is to go check whether or not there's any reproduction materials. And we call that the reproduction package. If there's any reproduction materials, they can move forward. If there's not, we ask them to report that or contact the authors to see if the authors can facilitate some reproduction materials that can be used for this exercise. In either case, we want to record that exercise and leave a record for that. To learn more about the reproducibility of a paper, but also we're trying to group all these responses in a centralized fashion, such that original authors are not asked twice or multiple times about the same things. So if our original author says, these are all the materials that I have, please do not contact me anymore, they can leave a record for that in our ACRE platform, and the idea is for them not to be asked repeatedly about the same things. And once there is a reproduction package, then they can move out of scoping. There will be, we will ask them to summarize the paper. We'll ask them to identify the claim that they want to reproduce. What's the display item associated with that claim, and what are the specific specifications that they think are where the main result holds. And then they will move into assessment. And here I'll stop for a second. I know there might be some confusion around scoping, so if somebody has any questions around it, happy to take them. Okay, so I'll move into assessment. The idea of assessment is to identify all the pieces in a reproduction package and then try to reproduce a specific display item, table, figure, or something like that. So in the first step, we ask the reproducers to look in the reproduction, first look in the paper and look at what are the data sources that are described in the paper in narrative form. So we use the current population survey, something like that. And that's the data source. And then we ask them to map that data source with any specific raw data files that they might have in the reproduction package. Then we ask them to identify what are the analytic data sets, defined as the ones that are used to obtain the final estimates presented in a paper. And we ask them also to inspect the code files to identify everything that goes into a code script and comes out from a code script. And with all those elements, we ask them to submit them to our platform in a standardized way. And with that, they can build with a tool called the ACRE diagram builder. They can build a reproduction tree. That is something that looks like this. If the workflow is complete, and this basically is the display item, the table 1, for example. And these are all the elements that are required to reproduce that display item. In several cases, this will not be completed, and the reproducer will use this tree, their incomplete tree, to identify missing pieces or suggest where the missing pieces might be. And we also think that having this type of documentation might facilitate a more constructive collaboration with original authors, as I will explain later. Once they have all the materials and they have a clear understanding of everything that goes behind a display item, we'll ask the reproducers to score the reproducibility of that particular display item. So here we have come out with a 1 to 10 scale, 1 being the lowest, 10 being the highest. And the way we think about this is level 1, it's pretty straightforward in the sense that no materials is a level 1, but as there is code and data, raw data being the one that gives you the highest level, analysis data being the one that gives you the initial levels. As you progress through those requirements, you increase your score, and there's going to be a difference between having partial materials and complete materials. So both for analysis code, for analysis data, and an important level to achieve would be to achieve computational reproducibility from analysis data, or CRA. And the idea is that if you have analysis data, if you have analysis code, and you obtain the same results, your paper gets level 5. And then if you move to the same idea through cleaning code and raw data, you get to computational reproducibility from raw data, or level 10. One thing that will happen is that some data will be confidential or proprietary. So we need to modify this for that case. And this is our suggestion. The main emphasis is that when there's no data, we ask reproducers to look for detailed instructions of how to obtain that data. So as opposed to having data here, the idea is to have instructions for the data. And that will change some of the levels. So we'll change level 3 and 4. I suppose this will not mean access to data, will mean have access to instructions. And level 5 you cannot test the computational reproducibility from analysis data. You can only, where we ask for reproducers to look for proof that a third party was able to reproduce the results. And this is something that companies are starting to emerge, like ACRE in France that does this, but we can also, we're open also to ask that original authors submit a reproduction by a third party, not involved as an author in the analysis. And same idea for computational reproduction from raw data. That's assessment. And before I move into improvements, I'm happy to take any questions that there may be. Okay, so in terms of improvements, there are 3 main types of improvements that we're interested in capturing. One, it's improvements at the paper level that make the entire paper more reproducible. Improvements that make a specific display item more reproducible, and improvements that were not able to, that the reproducers were not able to carry out, but in the process of inspecting the materials, again, they generated new knowledge in that they figure out that there are specific things that can be improved that they might not have the time, but they leave a paper trail or a instruction for future reproducers to work on those type of things. So paper level improvements, and this is, again, these are just suggestions that we put out, but happy to learn more improvements as computational practices on computational reproducibility improves, but things like using version control, improving the documentation, reorganizing the materials, following standardized best practices like the tier protocol. There's a new AEA reproduction template that also can be followed, using a literate programming environment like Jupyter Notebooks or R Markdown. Rewrite the code using different statistical software, ideally open source, but any type of different software already, it's an improvement. And setting up a computational capsule also can, those are the type of paper level improvements that we think of. In terms of display item level improvements, we think of adding missing data. There might be some data that at the time got lost, and the reproducer can go through a work of finding those files. Same idea with analytic data, and these are examples of a pilot that we have run, so students have done this. Adding missing analysis or cleaning code. So again, there could be, here's an example of something that a student did. They replayed a specific code to execute a statistical test, and debugging code also. So here there was an error, apparently it was fixed. And those are the types of improvements that we think. And again, not a comprehensive list. If somebody has another suggestion of how to increase computational reproducibility, happy to, please, you can email us, or you can create a pull request for these guidelines that I will show you at the end. With all that, once you have the entire machinery of the paper, you have a clear idea of how reproducible it is. Then we move into robustness, checking the robustness of a paper. And we break this stage into two parts. One, it's to increase the possible number of robustness tests, and the second one is to justify the appropriateness of a specific test. Let me explain in a little more detail. So the way we think about a paper, the way we think about robustness checks, it's any possible computational change, both in data analysis and data cleaning. So that leaves a very large universe of robustness tests. Within the universe of robustness tests, there's the subset of reasonable tests, and here by reasonable we follow Simonson et al. In terms that a definition of reasonable is one that is a test, one that achieves three goals. It's a sensible test of a research question. It's expected to be statistically valid, and it's non-redundant with other tests. And within the set of reasonable tests, you will hopefully find the paper. And another set is going to be the feasible reproductions. How can you feasibly reproduce specific components of a result? And the idea is that we use this diagram to think, okay, a reproducer can contribute in increasing the green set, increasing the feasible set. So identifying where the analytical choice that lead to reproduce a specific result. So that would increase the feasible set. And a second type of contribution that is much more subjective and requires much more substantive knowledge of the specific paper is about justifying a specific robustness check. And we think that the first type of contribution can be done from an undergrad or from a researcher that is not has an in-depth knowledge of the specific topic. But we think that the second type of reproduction has to be defend in detail and described in detail by somebody who's much closer to the field of the paper. And of course, the size of the feasible set is going to depend directly on these levels that we present at the beginning. So if there's no materials, the feasible set it's null. If there are some materials, but you cannot reproduce anything from the paper, you might be able to get some results, but they are not in the paper. If there's a computational reproducibility from analysis data, you can get some of the results of the paper. If there's a computational reproducibility from raw data, you can get everything on the paper and more. And that's how we think of robustness. That's the end of the exercise in terms of recording the different stages. So before I jump into this other slide, I will open up if somebody has some questions about robustness or any of the previous stages. Okay, so the one element that I emphasized at the beginning is that we do want to promote a constructive exchange. We want to move as far away as possible from these adversarial tones. So one thing we did is that in the guidelines, we created a chapter that guides both reproducers and authors on how to talk about sensitive issues. So we have template emails that for reproducers that guides them on how to ask for a reproduction package, on how to ask for additional materials or missing components, and all sorts of scenarios. So just to give you an idea, I want to just show you one example. Here we're saying, okay, this is the scenario where a producer has a reproduction package, but there are some materials that were lost, that cannot be found. So we suggest that this is how they should approach them. And we say, unfortunately, I ran into a few issues as I delve into the reproduction exercise. I think your guidance would be helpful in resolving them. And then we say, describe issues how you have tried to resolve them. Describe everything you have. and refer to examples that we point in the guidelines. And just to give you an idea of how much detail we suggest, we say this is the description of a well-described issue. So we say a well-described issue, it's something like I'm attempting to reproduce this specific table, this specific figure. I found the following components, but these other components are missing. I cannot obtain them. So this circles back to the reproduction tree and says, this shows that the reproducer has done the work in looking for the materials, has organized a little bit more knowledge on how the reproduction packets work. And now it's saying, please help me find this specific file again in a constructive, collaborative fashion, and emphasizing that if you original author ask me, help me reproducer, this will ensure that you will not be asked twice about this in the future, because this will be recorded in the ACRE platform, and the idea is that there will be a process for you not to be asked again. We want to point out to one reason for instructors that they might have to adopt this framework is that it also makes it for easy to grade this exercise, because we are working on generating these automated reports that will take each of the responses that students have created in the platform and create something like this that says, okay, there are 2 entries in ACRE around this paper. In terms of, for example, assessing the number of claims in a paper for this specific paper in the ACRE platform, on average, reproduces, I think that there's 4 papers. The standard deviation 0, so that means that they all agree that there are 4 claims. There's more variation in how many claims they choose to reproduce per exercise. We ask them to catalog them as causal or descriptive, and then do assessments on other things. And particularly when it gets to the claim level, here we just reproduce the summary that they create of the claim that they identify on a paper. And we also ask them, okay, for this claim, where is that the preferred estimate? So in this case, it would be the 1.169. The reproducer identified that number to be in table 2, page 917, in row 2, column 2. So then the instructor can say like, oh, okay, I will look at the paper and we'll find where's this table 2 right here, and it will be row 2, column 2. So and that will be the key result. So we hope that this is going to facilitate assessment of the exercise, and we think that this can fit into different formats. So the exercise could be a 2-week report to be written as part of the class, could be a 1 month as a more in-depth reproduction, could be even a full semester. And here we envision that undergrads could do this as their thesis also. We have done one successful pilot around this and it worked fairly well. And the only thing we point out is that the emphasis on these different stages will vary depending on the level of effort for the exercise. And this is a suggested distribution of time. That basically wraps up on what is the platform. Now I want to show you briefly what what I just wrapped up what the guidelines are, and now I just want to show you briefly what the platform is. And basically, we have a website. I think I'm sharing the. Are you able to see this? Okay. So this is the platform, Social Science Reproduction, where you sign in. I think right now that you can sign in. So you can sign in with Google, with Gmail, or GitHub. The password's still not the other one. It's still not ready. But once you sign in, you can see your reproduction attempts. and you record a candidate paper, start with the scoping part, and go through the motions of filling in the information that I described, identifying a candidate from a declared paper. Then you move into the assessment stage and so on. And basically, the idea is that later on all this information would be, people will be able to discuss about these reproductions in a forum. And also we will aggregate the reproductions to say something about the reproducibility levels of economics in general. And again, if we have enough observations per paper, we might be able to say something about a specific paper. As I said, the platform, we're aiming to have it up on beta version fully up for November, early November. So keep an eye for that. And the guidelines, these are the guidelines that are already public in this URL. And it's basically, these are the guidelines, one chapter per stage. We also have the additional chapter on guidance for a constructive exchange, examples of reproduction trees, and try to guide the user as much as possible in this exercise. And again, if you have a contribution, if you think that this can be improved, contributions are welcome. So you just click there and edit, and you can edit it, create a pull request right away on GitHub. So I think that's it. Yes. This initiative, it's funded by Arnold Ventures. We thank everybody who has participated so far in this project. And students have worked on the pilot version of this project. The students graduate development economics course at UC Berkeley, and an undergraduate student from Dina Pomerantz and University of Zurich. These very good looking slides, I took the template from this person, Grant McDermott. And I think that's it.